It's asking about octal number 127 in decimal, octal number 127 in decimal. So what you have to do is you have to take the positional values. 7 is 8 to the power 0. And then you have 8 to the power 1 and 8 to the power 2 consequently. 8 to the power 1 and 8 to the power 2. 7 is 8 to the power 0, correct. 8 to the power 1, that is this one, and 8 to the power 2 is this one. So what are the values? 8 to the power 0 is? Yes, you have to tell the answers. Even though I'm discussing, you have to give your support. 8 to the power 0 is? Yes, Vanshika?
1.
1. Okay. So 8 to the power 1 is 8 and 8 to the power 2 is 8 into 8, which is 64. So 64 into, you have to multiply by the digit. 64 into 1 plus 8 into 2 plus 1 into 7. Multiply by the digit and add it. 64 into 1, 8 into 2 is 16. 16 plus 64 is 80. 80 plus 7 is 87. 87 in decimal. And this is how you get the answer. So if you have any doubt, please ask, right? So you have to take the positional values, then multiply by the positional values and the digit value, and then add it. Then you will get the answer. It's 87. So the answer is 87. It's correct. Next. All right, arithmetic and logical. So this is actually, this need to be manually graded because minor errors, if you have minor errors, you are given less marks, right? I'll add these marks, don't worry. Arithmetic and logical unit, this is correct, right? Even without n or with n, that is correct. I'll give the marks for that one. Control unit is ZU, central processing unit CPU. UPS is uninterruptible power supply, correct. Integrated circuits, maybe circuit, hari? Integrated circuit, right? Circuits, maybe circuit, hari? Other than that, others correct, right? AL, this is correct, this is correct, this is correct, this is correct. Integrated circuit, not with the S. Very large scale integration. So this is also only one spelling error, so can be given the marks, it's okay. Large scale integration can be given the marks. Ultra large scale integration can be given the mark here. Random access, 1C is missing. So check the spellings, right? So when you're doing this, I'll give the marks. This, except the circuits part, I'll give the marks like 30 out of 33. So I'll manually add these marks, but so that will really change your marks. You will get more, 15 more. 15 more means 77. Your mark will be increased to 77. I'll manually update and put it. But next time, concern about the spelling mistakes, right? That's why I'm manually grading this. That's why I'm manually grading this, because if you have errors, then I can correct that. But in the exam, consider more. Please provide exact same spellings. But for spelling mistake, you won't get much marks deducted. But in some cases, you might get a deducted. That's why. Samara වෙලාවට ඔයාලට අඩු වෙන්න පුළුවන්. In the spellings concern කරන්න. අනිත් අයටත් එහෙමම තමයි. හරි. Timasha, you are here. Yeah, Timasha here. Let's go and see her one. එතනත් S එකක් දාලා තියෙනවා. Circuits කියලා දාන්නේ. මේක හරි. මේක ප්‍රශ්නයක් නෑ Timasha. This input, basic input / output system, that is okay. You will get mark for this one. S එකක් වැඩිපුර දාලා තියෙන්නේ ඇයි? Right, okay, anyway, so you'll get marks for this one, right? But the think about exact spellings next time. Akash, oh, Akash, all ලියලා නැහැ සමහරව පුතේ. Basic boot-in input operating system නේ, basic input output system. ලියලා තියෙනේවා හරි, some spelling mistakes are there. For those spelling mistakes, I'll give marks, right? Anyway, I'll give marks for this is central control unit, right? Control unit, not central unit. This is wrong. Control unit. Right, please see the answers, right? ALU, arithmetic and logical unit. CU, control unit. If you don't know, please take down now. CPU is central processing unit. UPS, uninterruptible power supply, correct. IC, integrated circuit. VLSI, very large scale integration. LSI, large scale integration. ULSI, ultra large scale integration, correct. RAM, random access memory, correct. ROM, read-only memory. BIOS, basic input output system. Okay, so it seems almost this is correct. Other than this S can give marks, right? Okay, the next one. Technology used in the first generation is vacuum tubes, correct. What is the second generation technology? Yes, second generation technology. What is that? Hello, can you hear me?
Yes, sir, can hear.
Yeah, can you hear me? Hello. Because I have just changed my network. Can you hear me or not?
Yes, sir.
Can hear, sir.
What is the second generation technology?
Transistor,
Transistor. Third generation?
integrated circuits,
I see. Fourth generation?
Large scale integrated circuits.
Large scale integration and very large scale integration. Another name? You can tell microprocessors, right? Microprocessors or large scale integration and very large scale integration. Fifth generation?
Artificial technology.
Artificial intelligence as well as ultra large scale integration. ULSI and AI, artificial intelligence, right? Okay, next one. Binary number equivalent to this. Again, you have to do the take the positional values at them. That is, method positional value. Positional value is 1. Positional value is 2. You don't have 2s. Positional value is 4. You have to add 4 to this. Next positional value is 8. You don't have. Next positional value is 16. You don't have. Next 32. You have 1. Next positional value is 64. You don't have. 128. You have 1. Next positional value is 0. Sorry, 1256. Then 512. No. 1024. Yes, you have 1024. Add them up. 128 plus 32 is 160. 160 plus 24 is 184. 84 plus 4 is 88. 88 plus 1 is 89. 1189. Correct. Answer is correct. Why it is required to learn number systems when using and learn in computers? Explain in the example. Number systems representing the numbers using the computer commands on and off. Correct. So, so this is like 8-point question. So when I consider about all 8 points, the problem is whether the answer is sufficient. Oh gosh. Okay. Problem is whether this is sufficient. It's required to learn number system learns in the computer because data are represented using symbols in the computer. Signals are represented using numbers. This is good. They will mean this is good. It's logical. Yeah. When typing letters and words using numbers, those letters represented by the computers, it can understand. While the computer numbers in the system values, these numbers depend on the position. Because consider computer to be. Okay. This is also good. Lavanya. It's used in programming, but it is partial, right? Okay, so let me give explanation, right, to this, because yeah, I think better to explain this because the logical points needed are missing here. Okay, let's write an explanation in your notebook or in your writing book. Why number systems are required. Why number systems are required. Okay, let's go point by point. So when it comes to an electronic device, okay, the smallest example, let's take bulb. What bulb can understand? What are the status in the bulb? Yes. Take a bulb. For an example, take a bulb. What are the status? Yes. Timasha, what are the status of a bulb? Oh, Anuja, what are the status? Bulb එක මොනවාද status තියෙන්නේ? තියෙන්න පුළුවන් status මොනවාද? Bulb එකක් තියෙන්න පුළුවන් status. ඔයාලගේ ගෙදර තියෙන bulb එක හිතන්න. කාමරේ
On
තියෙන
and
bulb
off.
එකක් හිතන්න. Yes.
On and off.
On and off. Correct. Switch එකක් තියෙන්න පුළුවන් status. In a switch
On and
also,
off.
yes, on and off. Simple. Two status, on and off. Two status are there, that is on and off. So in electronics, we need to represent these two status. So if it is a bulb, if it is a string, basic string element is a bulb. String එකක් හැදෙන්නේ bulbs වලින්. LEDs or whatever, liquid crystals or anyway, that is the representation unit for a string. And all the logics, everything works according to switches. ALU, CU, those are working according to switches, switch behaviors and bulb behaviors. So basic string element need 1-0 status. Basic logic element need 1-0 status, on off, 1-0 status. And in the other hand, if it is a pictorial element, a picture, a visual data, so that is also represented using number. Visual data is also represented using a number. For an example, let's take a color in HTML. HTML color is a visual data. So it's represented using red, green, blue, red, green, blue. So value will be between, if no color 0, the maximum color 255. So this is how you represent. Actually, this is in the decimal, but if you want to represent this in hexadecimal, it is in hexa. In hexadecimal, this is 00 to FF. In binary, this is 00 00 00 00 00 to 111111. So this is how the color is represented. If it is sound, if it is a letter, so let's say letter A. Letter A is represented using hexa 41. And in decimal 65. The same, that is similar to binary 100 000 01. So in the letters also you need numbers. To represent letters, you need numbers. To represent colors or visual data, still you need numbers. And if it is a sound, audio data, also needs quantization, sampling numbers. It also needs the quantization and sampling numbers. So that is how the audio data is represented. Since everything is represented using a number, it is better to have a number-based representation. Everything is represented in a number. So please write down under that. In computers, everything is represented by using a number value. Everything is represented by using a number value. So you can tell the examples, examples, and these are the examples. Letters. Letter A has a number. If you take letter B, B has a number. Simple letters, those are having numbers. So you can show this. Right. So now you know everything represented using a number value, and audio data and even video data, everything. So in a computer, everything is represented using number value. So therefore, we need a system to represent these in the computer for storing and communication purpose. So we need a way to store and communicate that. Simplest way is by using two status logic. Simplest way is by using two status logic, which is represented by using binary number system. Since it is lengthy, it will be shortened by using octals. So that is done by writing 3 by 3. Or hexadecimal by writing 4 by 4. So that is why those numbers are required. So for example, 10000001 can be written as, if you want to write 3 by 3, you can write this as so this is wrong, right? This has 1, so additional 0. Please correct this as soon as possible. Please correct this. This is wrong. So binary is 1 0 triple 0 double 0 altogether 1 2 3 4 5 zeros, right? 5 zeros. It's wrong. That's why. Okay, now we can see it's 101 in octal. And if you write the same in 4 by 4 manner, this 4 and this 4, it is 4 1 in hexadecimal. As a signal, you can send this data high, low, 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 and high voltages. So you can send it 1 0 0 0 0 0 1. In optical discs, we can write this as pith. In optical disc, you do write this as a pith. Land, and pith. In optical discs, you write as pith, land, pith. In magnetic disc, still we didn't discuss about this technology, right? In magnetic discs, we can write this as north south, south north, south north, south north, south north, north south. 1 0 0 0 0 again 0, south north and north south. 1 1 2 3 4 5 zeros, 1 5 zeros, 1. So that is why this two-state logic is very important, because it can easily be converted to a electronic format, either voltage or magnetic format, or it can be converted to optical format, or it can be converted to electronic format on off. Okay, so please write that and show. So please let me know once finished, right? Please let me know once finished, otherwise I'm infinitely waiting. Just let me know once done. Right, let's see the next question. Question number 8. What is the technology used in the second generation, the CC one? Again, transistors. So the next one. So binary number in octal and hexadecimal. So what you have to do is you have to shorten this. So we have already practiced that in the previous one. Take 3 by 3, 3, 3, 3, and 3, 5, 4, 2, 2. This is now 2, 2, 4, 5. In octal, in hexadecimal, let's try the same. So you have to refer to the table, right? Some table is in my mind, right? But I think you have the table with you now. So because already we have discussed this. Now this is 5, 10, A. So this is 4, 10 means A, and this is 5, 4, A, 5. Okay, answers are correct. Next. Okay, so this one is not correct, right? You have just not linked this. Use AND or NOT gates to create the logic circuits of these, and use NOR gates and also write the truth table. So this, for this actually you have to link your you link your Word, link a Word document after creating this. So MS Word is free for you, because if you are using Edmodo, if you are having an Edmodo account, so we are having Office 365 installed, added to the Edmodo, so you can use that. You can create Office 365 documents, and then you can link it to the paper or link it to the profile. So even you have not linked, if you have done this in Office 365 document and forwarded that to me, that's enough. Right? So how to do this? Basically, when you go to the Edmodo, you can go to your profile. You can go to the profile, and here you can see Microsoft Office is there. When you click this, you can see the Microsoft Office icon, and just click that, and then you can create Word Online or PowerPoint Online or Excel Online, right? And then you can even connect to the OneDrive and the exam, whatever. So Word Online, let's go to the Word Online, and you will get a new window. And with that, you will get the requirement Word document. So because this Office 365 version is now, we have it for. So then after doing that, you can go to the file, and so you can either download or you can just send it. So either you can share it or save to the Edmodo. Anyway, this will be saved to the Edmodo. The location will be Edmodo library. You can just rename that and save. Right? So Office is free for you if you don't have in your computer, but still you can use it. Phone, I'm not sure. For in mobile phone, I think there should be features, but not sure whether you can do this. But the mobile phone එක උනත් ඔයාලට access කරන්න පුළුවන් website. You can access the website using Google Chrome and do this. That's possible. Okay, so let's see what is the answer for this one. A and B not. A not and B. So let's go and create one. Let's try to find the answer for this one. Okay. Right. Okay, this is the one A, B not.